Two boats take off from a harbor at the same time. The first travels at 12 kilometers per hour on a bearing 077 degrees, while the second travels at 18 kilometers per hour on a bearing of 143 degrees. Calculate their distance apart after 3 hours. So two boats take off from a harbor at the same time. So let's come label the harbor H. The point H. The first boat travels at 12 kilometers per hour on a bearing 077 degrees. And the second one travels on a bearing 143 degrees. And then let's call the first one, let's say A. And the second one B. So from here to here, okay, so let's join them together. So here to here, 077 degrees, and from here to here, that's 143 degrees. So to get the distance, we're going to say speed is equal to distance over time. Distance equal to speed. The distance from H to A, the distance between H and A. So distance HA is equal to speed 12 kilometers times. Calculate their distance apart after 3 hours. So 3 hours is the common is the time. So 12 times 3, that's 36 kilometers. HB equals to 18 times 3. 18 times 3 will give us 54 kilometers. So here is 54 kilometers. And here will give us 36 kilometers. And then we should get this angle. So A, this is A, and this is B. So A is equal to A plus 77 degrees equal to 90 degrees. Y complementary angles. So A is equal to 90 degrees minus 77 degrees. That will give us 13 degrees. The next angle we're going to look for is let's look for this first, angle C. The reason why we're going to look for angle C is that once we get the value of angle C, we already know that from east to south is 90 degrees. So these two are complementary angles, so we can get B from C. Let's get C first. And then C and angle B, they are complementary angles in the sense that we have here. So this is 143 degrees, and 143 degrees is B, taking place of angle B. So and then this is C. C, these two are supplementary angles on a straight line. So B plus C is equal to 180 degrees. Y supplementary angles or angles on a straight line. But this is 140 degrees, so 140 degrees plus C equal to 180 degrees. C is equal to 180 degrees. I do not need this B. B here is this angle. Uh, B here is this angle from east to this line. So I'm not going to use B here. So 150 degrees plus C is equal to 180 degrees. So C is 150 degrees. So C is equal to 180 minus 140, 37 degrees. So since C is 37 degrees, C and B, B plus C, B plus C is equal to 90 degrees. And that's complementary angles. Complementary angles. So because both of them are in this quadrant, this second quadrant, and this second quadrant is 90 degrees from the east to the south. So since we know C, we can know B from this relation. So B plus C is at 7 degrees, equal to 90 degrees. So B is equal to 90 degrees minus 37 degrees. And this is equal to 90 minus 37, 53 degrees. So B is 53 degrees. Altogether, A angle HB, A angle HB is equal to A plus B. And that's equal to angle A is 30. Angle A is 13 degrees plus 52 degrees, 66 degrees. So what we have now is an included angle and two given sides. And we have to look for the distance apart, distance of the two poles apart after 3 hours. After 3 hours that they've left the harbor. Okay, so and that the distance apart is AB. So using the cosine rule, we have here line AB squared is equal to 36 squared plus 54 squared minus 2 times 36 times 54 times cos 66 degrees. Okay, so this is equal to 1296 plus 296 minus 2 times 36 times 54 times cos 66 1581 1581.09 1296 plus 2916 4212 minus 1581.29 1581.09 260.6. So now AB plus square root 260.61. Line AB 51 1.289. Okay, so let's cut our answer to three significant figures. AB equals to 51.3 kilometers to three significant figures. An aeroplane leaves an international airport and flies due north for 1.5 hours at 500 kilometers per hour. It then flies for 30 minutes at 800 kilometers per hour on a bearing of 53 degrees east. Calculate its distance and bearing from the airport. Let's get our distance. Speed is equal to distance over time. Again, distance is speed times time. An aeroplane leaves an international airport and flies due north for 1.5 hours at 500 kilometers per hour. So, um, first of all, let's plot the. Let's say this is the aeroplane. This is the airport, rather. This is an airport. A point A due north this way, and then from here due north, and then on a bearing north 53 degrees east. Not 53 degrees east. Should be here. 53 degrees east. Right, so join the path together. Okay, and call it 53 degrees east. Okay, and of course, so this will give us the shape. So let's call these points A, B, B, and then point C. And of course, remember that this is the airport. This is where the plane started off. So AB's distance of due north, when the plane moved due north, flew due north, it took about 1.5 hours at 500 kilometers per hour. So the speed is so AB is 500 times 1.5 500 times 1 2 plus 1 3 over 2 2 here 1 2 here 250 250 times 3 will give us 750 kilometers. So that's the distance. 750, yes, 750 kilometers. And then AC, line AC is equal to 30 minutes at 800 kilometers. So the speed is 800. And here the time is given in minutes, where the unit for speed is kilometers per hour. So we need to convert 30 minutes to hour. So that will give us 30 over 60. Since 60 minutes is equal to 1 hour, and then 30 minutes is equal to x hours. So x times 60 cross multiply, that's 60x into 30, and x equal to 30 over 60 hours. So 0 cancels 0, 2 here 1, 2 here 2, 2 here 1, 2 here 400. That's equal to 400 kilometers. So in that way, so that means that our shape will be different since this part is longer than this part. So I'm going to draw it again. Northward. Okay. So it's not going to be a straight line. There's a north. There's a mix. Let's say the point C is supposed to meet like this. Okay. Let's see. So here's 750 and here will be 400 kilometers. 400 kilometers. Of information given to us is that the plane flew due north. What I drew here is information I drew, diagram I drew from the information is that the plane flew due south, which doesn't correspond to the kind of diagram that we were supposed to have if we followed this information. So I'm going to draw it again. Now, an airplane leaves an international airport and flies due north. So let's say from here, let this be point E. Due north will be this way. Then so due north, that's due north. Okay, and then from here, so that's this due north. This the airport in this due north. Let's call here point B, and then from here, the distance from here to here is AB is 750 kilometers, and then from here north is 0 degrees east, which should be like this, and that is north 53 degrees east. Okay, so you join these points together. Perfect. Let's call this point C. So this is going to be our resulting diagram. The other one was I drew it from southward, but the question says due northward or due north. So I have to draw the diagram again. So now BC, so AB is 750 kilometers to BC. So I'm going to change this relation to BC. So the distance BC is 400 kilometers. So what we're going to look for as distance will be AC. So we need to get this angle. Of course, we got every information we need. So here is 90 degrees. Why? From the north to the east, it's 90 degrees. So we need to know this angle. So let's call this A. Okay. So now A plus 53 degrees. A plus 53 degrees equals to 90 degrees. Why? Complementary angles. A plus A is equal to 90 degrees minus 53 degrees. That is equal to 90 minus 53, 37 degrees. 37 degrees. Okay, so uh, A angle BC, is equal to A plus 90 degrees. 90 degrees plus A. That's equal to 90 degrees plus 37 degrees. 127. 127. 127 degrees. Alright, so we've gotten this angle, and then we have two sides. I'm looking for this side AC. So which of the rules do we use? Using the sine rule. Oh, using the cosine rule. Using the cosine rule, we have that line AC squared is equal to 750 squared plus 400 squared minus 2 times 750 times 400 times cos 127 degrees, and this will give us 750 squared. It's 562,500 plus 400 squared, 160,000 minus 2 times 750 times 400 times cos 127 minus 361 089.0129. Okay, close the bracket. So let's add this part up. 562 500 plus 160,000 722,500. Now minus times minus give us plus 361,089.0139. And this will give us plus 361,089.0139. That's 1083,589.014 and 014 which is a line AC is equal to square root 1083,589.014. So line AC is equal to 10.95595,956. Since the question did not tell us to how many significant figures, the answer should be left. I'm going to use my discretion. AC is 1040.96 kilometers to 2 degrees, 2 decimal places. So that's the distance from A to C. Calculate this distance and bearing from the airport, that's A to C. And then the next one says, and okay, calculate the bearing. Okay, calculate its distance and bearing from the airport. So the bearing from the airport, remember this is the airport where the plane flew from to point B and then from B to C. So the bearing from the bearing from the airport will be from this line. So this is not. So this line, let's call it alpha. Alright, remember that this angle is known and this side is known. So alpha against that. So using the sine rule, using the sine rule, sine 127 degrees over 1040.956 equals to sine alpha over 400. The sine alpha is equal to 400 sine 127 degrees over 1040.956, and sine alpha is equal to 400 sine 127 divided by 1040.956, 0.369. And alpha equals arc sine 0.3069. Alpha is equal to 0.3069 by 17.87 degrees. 17.87 degrees. So this tells us that therefore the bearing of C from E is 17.87 degrees. The bearing of Q from P is 150 degrees and the bearing of P from R is 0.15 degrees. So the bearing of Q from P is 150 from P. P 150. So 150 minus P 150. This is P. This bearing of P, bearing of Q from P. So this is Q is 150 degrees. And then if Q and the bearing of P from R is 0.15 degrees, the bearing of P from R, the bearing of P from R is 0.15 degrees. From R, so R 0.15 degrees. Bearing of P from R 0.15. So we come to R and plot 0.15 degrees. 0.15 will meet this one here. So okay, and this is 0.15 degrees. This is point R. Now, if Q and R are 24 kilometers apart, QR 24 kilometers. Okay, I'll write it again. 24 kilometers, and then 32 kilometers respectively from P. And if Q and R are 24 kilometers and 32 kilometers respectively, Q is 32 kilometers respectively from P. That's yes, 32 kilometers. This 24, this 32. So we join this together. We have the distance RQ. Calculate the distance between Q and R. We are looking for this. So that way we're going to look for this angle. We need to know this angle. We need to know this angle. So 15 degrees, 0.15 degrees to P. So we need here angle A and we need the angle B. And now we add all these two angles together. So from our analysis, when we say A is equal to 15 degrees Y, alternate angles, and then B plus 150 degrees equal to 150 degrees. This is supplementary angles or angles on a straight line. So B is equal to 180 degrees minus 150 degrees, and B is equal to 30 degrees. And so R angle PQ, R angle PQ is equal to A plus B. That will give us 15 degrees plus 30 degrees. And that's giving us 45 degrees. So this angle is 45 degrees. So RQ, first of all, the Aroma figure 1 says we should represent this information in a diagram, which is already done. So this is Aroma figure 1. The Aroma figure 2. Okay, we should calculate the distance between Q and R. So to do that, we're going to make use of the cosine rule. Using the cosine rule, we are going to QR and QR is equal to 24 squared plus 32 squared minus 2 times 24 times 32 times cos 45 degrees. 24 squared (576), 32 squared 1024 minus 2 times 24 times 32 times cos 45, 2 times 24 times 32 times cos 45 1086 times 1 1. That will be 576 plus 1024 minus 1086.11 513.89 line QR equal to square root 513.89 line QR. So this will give us square root 22 2.67. And okay, they don't tell us to, they didn't give us any specific significant figures to correct our answers to. So I'm going to leave mine in 3 significant figures, and therefore line Q is equal to 22.7 kilometers. So 3 significant figures. So that's for roman figure 2. Let's look at roman figure 3. Find the bearing of R from Q. Find the bearing of R from Q. So from Q, what do you think we have here? So from Q, we're going to have so the line is like this. This line. Okay, I need to make a little adjustment. If Q and R are 24 kilometers and 32 kilometers respectively from P, so this tells us that QP is 24 kilometers, but QP is 32 kilometers. That was so it doesn't affect the calculation here, but just it's going to affect. If I don't make the correction, it will affect the bearing result. So here will be 32 kilometers. So this tells us that this line should be longer than this one. So I'm going to start with this again and then from here. So this still is point Q, 24 kilometers. This is point Q. Alright. That's point Q, 24 kilometers. Now point R would be something like this. So point R. Okay. 32 kilometers. The reason for this is that if you are using construction methods to get these bearings, of course you discover that 32 kilometers will be longer than 24 kilometers. So it's going to affect the angle you're going to get or the bearing you're going to get. That's why you have to be cautious with the length of the sides. You don't just draw the sides anyhow, because it's going to affect the shape of the resulting diagram. So this will not give us, if you are trying to join these 2 points together, this is straight. So this will give us slightly. So this will give us something like this. So at the end of the day, you should be able to have, let me look at this diagram. Let me bring this one up a little. 24 kilometers, and this will give the north and the south. So this will go. So if you join it perfectly, I don't want it to curve. Yeah. Okay. So this is what you're going to have. As you can see that from what I've drawn, this side tilts upward a little because this side is longer than this side. So for them to join, it's going to look something like this. So at the end of the day, your bearing will be from here to this line. So you need to know this. Okay, you don't need to know that. So that was what our bearing will be like. So this is, so that's it. Okay, so that's the first thing we need to do.
And now to get the bearing of R from Q, this is point R, and here we said was what, 15 degrees. Bearing of P from R, so R is 15 degrees, 0, 15 degrees. So to get the bearing of Q, R from Q, this will give us from here to here is that, okay. So we need to know this angle. This is, let's call this theta, and then let's call here B and C. C. So what is C? C is equal to B, and that's equal to what? What's B? B is 30 degrees. So what is that? B is 30 degrees, and that's alternate angles. So since that is true, so I will say the bearing of R from Q is equal to, or is, let's say is 360 degrees minus theta, 360 degrees minus theta plus C. That's it. So now we don't know this value theta, so let's get theta. So using the sine rule, this is sine 45 degrees, and 45 degrees over the distance 22.67 for the sine theta over 32 sine theta is equal to 32 sine 45 degrees over 22.67 sine theta is equal to 32 sine 45, 22.6, 32 sine 45 divided by 2.6, 0.981. Theta is equal to sine 0.9981. Theta 86.47 degrees. So that's the value of theta. And we got theta because it's needed in this expression. So I'm going to say the bearing of R from Q is equal to 360 degrees minus 86.47 degrees plus C, angle C, which is here, and C is 30 degrees. It's 30 degrees. Now you give us 360 degrees minus 86.47 plus 30, 116.47 degrees. 360 minus 243.53 degrees. But our answer should be correct to the nearest degree. So approximately, so this will give us 244 degrees. So the nearest degree. A cyclist starts from a point X and rides 3 kilometers due west to a point Y. So due west will come this way. So let's start from here. X, point X, due west, okay, point Y. This Y. It changes direction and writes 5 kilometers northwest. 5 kilometers northwest. Northwest between the north and the west. Due west was 3 kilometers, so this extended line is not necessary. This is 5 kilometers. So I'm going back. So this is point X, 3 kilometers. It's 5 kilometers. Okay. So that is northwest. Alright. So the next thing is to join the 2 points together. So I'm going to start from here. Okay. So this is X. Okay, I'm going to call here Z. Point Z. So how far is it from the starting point? This is where it started. This is where the journey ended. So from here, traveled north and cycled due west, and from here to the northwestern direction. So and then this is the final destination. So let's get this angle. And so we're going to call this is north between here. So between the north and the east here is 90 degrees. And then let's call here E, angle E. Angle E. And then what else do we need? Find the bearing of Z from X. Okay. But okay, so let's work on this first. So A is equal to 45 degrees. A is equal to 45 degrees. How do we know the northeast direction? Northwest rather, northwest direction. Since if you are going from the north to the west, it's going to be 90 degrees. So the half of it is 45 because this northwest direction bisects the northwest quadrant into 2 equal parts. So from the north to northwest is 45, and then from northwest to the west is 45. So total 90 degrees, which is the total of each quadrant. So the A is equal to 45 degrees. And then so A, then Z, or let's say X angle YZ is equal to E plus 90 degrees, which is this total angle. And this will give us E, which is 45 degrees plus 90 degrees. And this will give us 135 degrees. So we have an included angle on 2 sides. So we are going to use the cosine rule. Using the cosine rule, xz by xz squared is equal to 5 squared plus 3 squared minus 2 times 5 times 4 times cos 135 degrees. This will give us 25 plus 9 minus 2 times 5 times 3 times cos 135 minus 21.21. 25 plus 9, 84. Minus x minus is plus 21.21. 55.1. So line x z is equal to square root of 55.1. Line x z is equal to square root 7.420. The nearest kilometer, so that will give us, therefore, line xz approximately 7 kilometers to the nearest kilometer. So when it means to the nearest kilometer, it means to the nearest whole number. Other kilometers or meters. If it's to the nearest degree, it means to the nearest whole number. To the nearest meter means round up or round off to the nearest whole number. Okay, so number 2, number figure 2 rather. Number figure 2 says find the bearing of z from x. Bearing of z from x is going to be from here like this. Because z, the line connecting z and x is this line, so you must rotate from the north until it gets to meet this line. So that will give us this angle, which is angle, let's call it beta, and then let's call here. Of course, this is northwest, so southwest, so this is going 45 degrees, but let me just say B, correctly, and then we have B, so let me call this angle B, and then from, okay, yeah, there's no point, already from the north to here is 270 degrees, so I can say B is 270 degrees, that's, so what you say, okay, no points. I'm going to say the bearing of z from x is equal to is equal to 180 degrees plus here plus for b plus 45 degrees, which is the, I can just say 270 degrees plus beta, and then it's okay, 180 degrees plus 45 degrees, 180 from here to here, 180 degrees plus 45 degrees plus beta plus beta. That's beta. B is equal to 270 degrees. So B is 270 from the north to the west, 270 degrees. So plus this beta will give us the bearing of z from x. So the bearing of z from x is equal to 270 degrees. 270 degrees plus beta. So let's get the value of beta using the sine rule. Using the sine rule. So sine 135 degrees over 7.42 equal to sine beta over 5. So sine beta 35 sine over 35 degrees over 7.42. Sine beta is equal to 5 sine 135 divided by 7.42, 0.47, 0.4758. This equals arc sine 0.47, 0.4758. Beta is equal to 28.41 degrees. So we say the bearing, therefore the bearing of z from x is equal to 270 degrees plus beta, that's equal to 70 degrees plus 28.4. 298, 98.41 degrees. Approximately to the nearest degree will give us 298 degrees. 290 degrees. So the nearest degree. In the diagram, A is a house which lies due east of a mosque. B. Feeder roads run from A to C and from C to B. A footpath leads from C to the point D to AB. The distance between these places are measured as follows: AC 58 meters, CD 71 meters, AD 96 meters, and A angle BC 28 degrees. Calculate A, the bearing of C from A, and B, the distance BD correct to the nearest meter. So what we're going to do, solution E. So A says we should find the bearing of C from E. So which means from the north point, these are points A, from the north. Okay, from the north, measure our line to meet this line. So from the north to this west is 270 degrees. So we need to know this angle. Let's see, theta. So we say the bearing of C from E is equal to 270 degrees plus theta. So to get to theta, we say in triangle ACD, the range of this triangle, the three sides are given in triangle ACD using the cosine rule. So this is A cos A is equal to B squared plus C squared minus A squared over 2BC. Cos A, and where A is theta, cos theta is equal to B squared. So let's take any random. So if so A squared will be this side, this 2 58 squared plus 96 squared minus 71 squared over 2 times 58 times 96 cos theta is equal to 58 squared 3064 plus 96 squared 9216 minus 71 squared 5041. 2 times 58 times 96 1 36 3364 plus 9216 minus 5041 7539 divided by 136 0.6 cos theta 0.6676 996770. So theta is equal to arc cos 0.6770. Theta is equal to 0.6770 47 0.09 degrees. So now that we've gotten the value of theta, we can find the bearing of C from A. Therefore, the bearing of C from A is equals to 270 degrees plus what? Theta. That's what 270 degrees plus what's theta? Theta is 47.39 degrees. 17.39 degrees. B. Find the distance BD correct to the nearest center. This part BD. But for us to get BD, we're going to consider triangle ABC. Let's get the whole length AB. So BD can be gotten triangle ABC. For triangle ABC. So which means that for triangle ABC, we know this angle to be 47.09. So let's get angle C. So B and A angle CB. A angle CB. A angle CB plus, which is C. A angle CB plus theta plus 28 degrees plus 28 degrees equal to 180 degrees. For the reason, sum of angles in triangle. So A angle CB, which is C plus theta, which is 47.09 degrees plus 28 degrees equal to 180 degrees. So C plus 28 plus 47.09, 75.09 is equal to 180 degrees. So angle C is equal to 180 degrees minus 75.09 degrees. C is equal to 104.61 degrees. So angle C, angle C is 104.61 degrees. Now using the sine rule, in order to get the low dimension, low distance AD, so sine 104.61 degrees over AD is equal to sine 28 degrees over 58. So A is equal to 58 sine 104.61 degrees over sine 28 degrees. So A is equal to 58 sine 104.61 and the rest sine 28 19.55 meters. So that's AB. But remember, but okay. So say but AB is equal to BD plus AD. So A, therefore, if you make this subject of the formula BD That will be A B minus AD. So B is equal to AB is 119.55 minus 80, which is 96. And this will give us 119.55 minus 96, 23.55, 23.55 meters. But BD to the nearest meter, therefore BD is equal to 24 meters. So the nearest meter. A point P is 40 kilometers away from point Q on a bearing of 0.33 degrees. Q, the point P is from Q, let's say Q, point Q. P is 0.32 degrees from point Q. Yes, P. And another point R is 65 kilometers. So this the distance here is 40 kilometers. Another point R is 65 kilometers from Q, and this one is 125 degrees. 125 degrees. However, the distance is 40, which is 65. So it's going to be more. Or the distance is going to be longer than this one. Okay. So this is 125 degrees. Remember, this is our cardinal point, our west direction. So let's join the lines together. So that's PQR. So that's what we're going to have. Okay, so here we need to know this angle. This is E, and we need to know here B. We need to know here C. Alright. So then okay. E is equal to, so there's our analysis here. So E plus 32 degrees is equal to 90 degrees complementary, and E is equal to 90 degrees minus 33 degrees. E is equal to 57 degrees. Then B plus, so B will give us, to get B, we need to remove, since from B here, from here to here, B is from the west to this line, and then from the north to the west is 90 degrees. So 90 degrees plus B is equal to 125 degrees. B plus 90 degrees plus 125 degrees. So B is equal to 125 degrees minus 90 degrees. B is equal to 125 minus 90, 35 degrees. B is 35 degrees. Now A plus B, to get this angle, and example is distance is 65 kilometers. This angle, P angle QR, P angle QR is equal to A plus B. And that will give us A is 57 degrees and B is 35 degrees. 57, that's 92 degrees. So before proceeding, it's important we draw this line accurately. So since this line falls here, and for you to join this point, bring this one here. Yeah. So that's it. Okay, so we are looking for PR, Calculate the distance between P and R. So using the cosine rule, using the cosine rule, PR and PR squared equals to 40 squared plus 65 squared minus 2 times 40 times 65 cos 92 degrees. 1665 squared 4225 minus 2 times 40 times 65 times cos 92. And do it again. 2 times 40 times 65 times cos 92 and 16.75 1600 plus 4225 5825 minus times minus is plus 16.75. So 16.75 5841.75 5841.75. So line PR is equal to square root 5841.75, and this is equal to square 76.43 kilometers. But we are going to give this, if you are going to approximate to the nearest meter, which will give us, or to the nearest kilometer, which will give us 76 approximately 26 kilometers to the nearest kilometer. Yeah, over figure 2, bearing a P from R, bearing a P from R. So bearing a P from R, be from the north to this line. So this angle that I marked, if we put, if first, if we know this angle, then this can become angle at points such that we know that from here to here is 180, and then from here to here we determine it. Then we get this angle. This is the angle of this triangle. Let's call it let's say alpha. So we solve for alpha using sine rule, and then plus this one, everything is equal to 360 degrees. Then we get the bearing, which is the whole of here to here. But we can't do this because we don't know this angle, and also the only way we could have known this angle is from here. That's alternate angles A here. But another way to go about it is that we already know that from here to here is 180 degrees. So let's call here beta. Let's call here B rather, or C. So let's say figure 2. The bearing of P from R. Bearing P from R is equal to 180 degrees plus B plus alpha. And B is equal to 125 degrees using alternate angles. Why alternate angles? Remember from here, you have here 125 degrees, which is not to this line, which is angle is not to this line, which is that's 125 degrees from here. 5 kilometers from Q and a bearing of 125 degrees are this connecting R, and then from the north also, sorry, from the south to this line, from the south to this line. Although from the south to this line you have here, which is what you have here, but it doesn't matter. What we are looking for is alternate angles, so this one does not count. Okay, so that's alternate angle. So this is the whole of C, and this is the whole of C here. So C is from the south to this line. Okay, so if already we know that from the north to the south is 180 degrees, and then B, not B, is C. These already used C, and then C plus C, which is here this alternate angle, which is 125 degrees. Then alpha, so let's determine alpha using the sine rule. Using the sine rule, sine 92 degrees over the distance 76.42 is equal to sine what? Sine alpha over 40. So sine alpha is equal to 40 sine 92 degrees over 76.42. Sine alpha is equal to 40 sine 92, 39.9756 divided by 76.42, 0.52920. So alpha equals to accent 0.5230, and then alpha is equal to 0.5230, 31.552 degrees. So we say therefore bearing of P from R is equal to 180 degrees plus C plus alpha. That is 180 degrees plus C is 125, and alpha is equal to 31.52 degrees. So 180 plus 125 plus 31.52 136.52 degrees. So that's your answer. So the nearest degree would be approximately 237 degrees to the nearest degree. We are going to make a little correction here. 2 times 40 times 65 times cos 92 minus 181.48. So minus times minus is plus, so minus 181.48. So answer here will be what? 5825. 5 plus 181.48. 6,006. 6,006.48. And that will give me square root 77. 77.50. 77.50. When approximated, it was 78 kilometers to the nearest kilometer. So 77.50, let me change this one here. 77.50. 77.50. So 40 sine 92 divided by 77.50, 0.5158, 0.5158. So arc sine 0.5158, 31.05, 31.05 degrees. So here's the 31.05 degrees. And let's add up again. 31.05 plus 180, or rather 180 plus C125 plus 31.05, 36.05, 36.05, and so the nearest degree will be 336 degrees. 336 degrees to the nearest degree.